Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with Laplace transform unit MCQ question, multiple choice question. Now L of 1, so L of 1 is nothing but the result, important result. L of 1 is 1 by S, option 1. So L of e power 3t, so L of e power at 1 by S minus a. For here L of e power 3t, a value 3, 1 by S minus 3, the option is B. And here L of e power minus at, 1 by S plus a, the result. So 1 by S plus a, option C. Option C. And then L of cos 2t, L of cos at, S by S square plus a square. Now L of cos 3t, a value 3, so S by S square plus 3 square, S by S square plus 9. Sorry, it's a 2 square. So 2t means 2 square, 4. S by S square plus 4, option A. And L of t power 4, L of t power n, n factorial S power n plus 1. So L of t power 4, 4 factorial S power 4 plus 1. So 4 factorial by S power 5. 4 factorial S power 5, option A. Then L of sin hat, a by S square minus a square. So here L of sin h omega t, omega consider a. So omega by S square minus omega square. So omega by S square, omega square, option D. And L of sin at, a by S square plus a square. L of sin 3t, 3 by S square plus 3 square, therefore 3 by S square plus 9. So 3 by S square plus 9, option B. Then L of cos hat, L of cos hat equal to S by S square minus a square. Now L of cos hat, a value 1. So S by S square minus 1. S by S square minus 1, option B. Then L of t power minus 1 by 2 is nothing but root of pi by S, option A. Now what is the first shifting theorem? L of e power minus at f of t is nothing but L of f of t, then S tends to S plus a. This is nothing but the f of S plus a. The first option, f of S plus a. Then L of e power minus at cos bt. This is a, so L of e power at into f of t. L of e power minus at into f of t is nothing but L of f of t, then S tends to S plus a. For this term, L of cos bt, then S tends to S plus a. Therefore, L of cos bt value S by S square plus b square, then S tends to S plus a. Therefore, S plus a by S plus a square plus b square. S plus a square plus b square, option B. And then L of t e power t. Now the form L of t f of t is nothing but minus d by ds of L of f of t. Therefore here minus d by ds L of e power t. So minus d by ds 1 by s minus 1. So when I am differentiating 1 by x minus 1 by s minus 1 square. Therefore 1 by s minus 1 square. The option is D. Now t into, so L of t sin at minus d by ds L of sin at minus d by ds a by s square plus a square. Therefore when I am differentiating this, u by v or minus a d by ds of a square plus a square. Therefore minus a, when I am differentiating, this is a whole inverse, n into x power n minus 1 into 2s, minus minus plus, so 2as by s square plus a square whole power minus 2. So 2as by s square plus a square when the denominator is a plus 2. Option A. So 2as by s square plus a square whole square. So this is the option A. And then, so this is a t into f of t minus d by ds f of s, option B. And t power n minus L of t power n f of t is nothing but minus 1 power n d power n minus 1 ds power n minus 1 L of f of t is a f of s. So this is a d by ds. So d power n by ds power n, option A. Then f of t by t. So L of f of t by t is nothing but s to infinity L of f of t into dt, sorry ds. Therefore this is f of s, s to infinity f of s ds, option B. Then L of f of t by t s to infinity L of f of t into ds. Therefore this term L of 1 minus e power minus t by t is nothing but s to infinity L of 1 minus e power minus t into ds. So s to infinity L of 1 minus L of e power minus t into ds. L of 1 value 1 by s minus L of e power minus t 1 by s plus 1 ds. When integration log s minus log s plus 1 s to infinity. So when I substituted upper limit and lower limit, log infinity, or should write in the form log of s by s plus 1 s tends to infinity. So when I am removing upper limit before because infinity substitute na every terms are infinity, before substitute infinity taking common s. So log of s by s, when I am taking 1 plus 1 by s, to cancel this s to infinity. So now substitute infinity, 1 by infinity 0, then log 1 minus when I substituted s, so log s by s plus 1. So this log 1 0, therefore this term minus log s by s plus 1. When I am changing this, log s plus 1 by s, log s plus 1 by s, minus log s by s plus 1 or log of s plus 1 by s, option C. And then initial value theorem. So f of t, so initial value theorem, limit t tends to infinity. So when we are finding the initial value theorem, final value theorem, suppose the problem verification, then we should verify, or the form limit initial value theorem, limit t tends to 0 f of t and limit s tends to infinity s into f of s. So now to find this term f of t equal to, so limit s tends to infinity s into L of f of t value. So L of f of t, limit s tends to infinity s into L of a e power minus bt. Therefore this is a I am taking constant out, limit s tends to infinity s 1 by s plus b. So when I am taking common limit s tends to infinity, s I am taking out 1 plus b by s. This s will cancel. So infinity to substitute a into 1 by 1 plus b by infinity. So a, option A. And the final limit, final initial theorem, limit t tends to infinity f of t, limit s tends to 0 s into L of f of t. Therefore limit t tends to infinity f of t equal to limit s tends to 0 s into L of 1 plus e power minus t sin t plus cos t. Now limit s tends to 0 s L of 1 plus L of e power minus t sin t plus L of e power minus t cos t. Therefore limit s tends to 0 L of 1 s into 1 by s plus this term 1 by s square plus 1 s tends to s plus 1 plus 1 by s plus 1 s square plus 1 s tends to s plus 1. So when we substituted this term, so it's difficult to simplify. When I multiply inside s, the value is s cancel 1, then other terms are 0, the value 1, option A. Then using final value theorem, same process. See, limit s tends to 0 s into L of f of t. Therefore limit s tends to 0 s L of t square e power minus 3t. Limit s tends to 0 s into 1 by s plus 3, so into t square, or t square, L of t square equal to 2 factorial s power 2 plus 1, so 2 by s cube. When 2 by s cube, this term 2 by s cube, s tends to s plus 3. Therefore limit s tends to 0 s into 2 by s plus 3 cube. When I substituted s, the whole term 0, because when I am taking s cube out, then 3 by s, substitute 0 now, 1 by 0 infinity, sorry 1 by 0 yes infinity, any whole term infinity, so substitute s tends to 0 0, the option A. Then inverse Laplace transform for this term, L inverse of 1 by s minus a e power at. So L inverse of 1 by s, 1 by s, see here, L inverse of 1 by s t. So L inverse of 1 by s square, it's a t square. L inverse of 1 by or e power minus t or e power t, t into e power t. So this term L inverse of, so L inverse of e power, this is a term L inverse of 1 by s minus 1 square. So when to find this, to remove this L inverse of 1 by s minus 1 square equal to, when I remove s minus 1, it coming with e power t L inverse of 1 by s square. So this is the e power t, 1 by s square is nothing but t. L inverse of 1 by s 1, L inverse of 1 by s square t. So e power t into t, the option is B. And then L inverse of f of s equal to f of t, then L inverse of f of s by s, the property is nothing but 0 to t f of t dt. And then L inverse of 1 by s square plus 2. So L inverse of a by s square plus a square sin at. But here L inverse of 1 by s square plus 2. Therefore L inverse of s square plus root 2 square, but here root 2 is not there, so root 2 by root 2. Therefore 1 by root 2 L inverse of root 2 by s square plus root 2 square. Therefore this term is sin root 2 t by root 2. Sin root t by 2, so option B. Now this is a L inverse of s by s square minus a square cos h a t. So L inverse of s by s square minus 9 cos h 3t. Cos h 3t. So the cos h 3, option D. Now this is a convolution theorem. If f of t star g of t is nothing but integral over 0 to t f of u g of t minus u into du. So therefore the term whatever we change 1 star e power t. So 0 to t. To consider this is a f of t, this is a g of t. Now e power u 1 du. So when I am integrating this, e power u integration e power u 0 to t. Upper limit e power t minus lower limit e power 0. So e power t minus 1. So the option A. Thank you.